Very good morning, everyone. Hi, good morning, everyone. My name is Daniel Wood. I'm the Managing Director Maritime at ABL. Our briefing this morning is accredited by the Chartered Insurance Institute, and delegates can claim up to 1 hour CPD for your participation. We will therefore keep a record of those of you in the room today and those of you logging on online. If you haven't done so already, please make sure you sign in with the team on the desk outside after the briefing in order to be able to receive your follow-up email and CPD certification. Just a quick reminder today as well, we will be ending the webinar portion of the briefing after the technical presentation, and the marine casualty case reports moving forward will only be presented in person. Of course, we are happy to discuss with anyone who would like to have more information on them post-briefing and to look at how we can make that data available to you. So please do come and see me afterwards. I'm delighted to introduce our technical presenters today. Robert Murdoch. Rob is a marine engineer with almost 18 years of seagoing experience. He joined ABL in 2023 and is now predominantly engaged in H&M casualty surveys. He will be presenting today's cable ship presentation. And to read this month's case reports, we have Oliver Tattersall. Oliver is a naval architect here at ABL and part of our graduate program. Thanks very much for joining us again, Ollie. Usual caveats apply, Chatham House rules apply, and the information contained in these presentations and any opinions or comments expressed are those of the presenters and not necessarily those of ABL. At the end of today's briefing, can we please ask everyone to take 3 minutes out of their time to complete the online survey? This is a critical element of our CPD accredited status. We want to be able to continue offering that opportunity to you to get 1 hour CPD per briefing. It also means that we can actively look at how we can improve these briefings to match your requirements and needs. Thank you. You can download it via this QR code, and we will also send it out in the follow-up. As these briefings are CPD accredited, a very important criteria of this is how to run through our learning objectives for today. So in terms of what you will learn, you will have a brief understanding of the history of submarine telegraph and telecoms cables. You will be able to explain the differences with cable ships. You will be able to understand cable laying machinery installed on cable ships, and you will be able to understand modular cable machinery, ROVs, remote operated vehicles, and ploughs. We will go over these again at the end of the presentation. So I'd like to introduce Rob to the stage. Thank you.
Good morning, everyone. Thank you, Daniel. Yes, my name's Rob, working here at ABL. As Daniel said, 18 years at sea, from cadet all the way up to chief engineer. I spent 8 of those years on cable ships, hence my presentation today. So yes, just a brief history of submarine cables. The first electronic transmissions by Samuel Morse, you see there. These became prevalent shoreside in the US and UK, transmitting telegrams up and down the country. With Anglo-American relations, there was a need for transatlantic communications. And you'll see there on August 1858 was the first transatlantic telegraph cable. This was installed. So telegraph cables, they were utilized. A few were installed up until 1929, but these were still only capable of sending telegrams. There was no communications other than written at that point. In 1951, you'll see the first TAT1 system, which is transatlantic telegraph or transatlantic telephone. I can't remember the exact name. This was installed, and this had 48 voice circuits, so capable of having 48 conversations running concurrently. So this was, there were many more cables installed. These were all analog copper cables. They gave way in the early 1980s, the mid 1980s, to fiber optic cables, as you can see there. And you can see the increase in capacity at now up to 40,000 telephone calls. So this capability of data transfer was very useful given the upcoming invention of the internet. So transatlantic cables were quite prevalent. There was also trans-Pacific cables, but there was a bit of a need in the late 90s to link these two communication systems up. So the first one there was 1997 was the flag cable. This linked the transatlantic and the trans-Pacific cables to sort of create a worldwide network. Interesting fact, my father was one of the oceanographers that worked on flag, but there we go. That's how I ended up on cable ships. So almost all of the world's data is actually transmitted. Electronic transmissions of data is via these cables. And as you can see there, this is a fairly recent map. There's a lot of cables out there, currently approximately 570. And as you'll see, 95% of the world's digital data communications is via cables, not by satellites, as I quite often get asked when I bring up this subject. With the invention of Starlink and everything, people seem to a misconception that satellites have taken over, but no, it's still 95% of data is cables. So moving on from that, how do we get the cables in the sea? So the first cables that were laid, they generally used older naval vessels that they converted with rudimentary machinery just to try and get the job done. And as we'll see there, in 1873 was one of the first purpose-built cable ships. So what are cable ships? So purpose-built cable ships there's a couple of pictures up there. I've sailed on 2 or 3 of those. They tend to be a little bit more expensive to build as they're very specialist. You can't just go to a shipyard and say, I'd like a cable ship. They don't have hull forms ready to go as they do with container ships, flatbacks for DP purposes, things like that. But these purpose-built vessels generally are a lot more capable. They're designed to work in harsh conditions, transatlantic, trans-Pacific. They can hold their positions well whilst doing the job they were designed to do. Conversely, we can have some slightly cheaper alternatives. You can take existing vessels and add machinery to them and convert them into cable ships. There's a Ro-Ro there on the bottom left. I sailed on that, and I also sailed on the Ro-Ro sister ship. But there we go. Flatback DP vessels, obviously they already have DP capability. They're quite easy to convert with a large back deck. So yeah, they're the general vessels you'll see out there doing the cable work. So structurally, as you'll see, large bow sheaves or stern sheaves, depending on whether the vessel's a bow or stern worker. The reason for these sheaves is fiber optic cables utilize a glass fiber core. Each fiber is only the width of a human hair, and they tend to have sort of 12 to 24 fiber pairs within a cable. These have a minimum bending radius. If you bend them too tight, the glass will snap. So these bow sheaves allow for a minimum bending radius to be observed, but also allow you to pull a bit of tension, because you can imagine the weight of a cable at 7,000 meters in the ocean up onto a ship. There's quite a lot of tension gets pulled on that. So this vessel, for instance, has 2 bow sheaves there. There's actually 2 rollers at there, so you can work 2 cables at a time. This is necessary when you're doing cable repair. You need to be able to have one side of the cable and the other side together and move up and down the line of the cable. They tend to have a large main working deck. Difficult to see. I couldn't really find any photos. Going back through all my old photos, I don't have a big overview. But they will have a main working deck, which will have the jointing rooms on board. But they also have hatches there to access the cable tanks, which are sat below. And most cable ships will have large... That wasn't me. I just wiggled the cables. It's all right. No, I just wiggled them to get it back. I'll put my hand back in my pocket. Yes, so cable tanks. These are open tanks of which the cable can be coiled up into to hold this during laying operations, or to take stock if you're going out to do a repair. So on the cable tanks, generally two different types. You have the traditional telecoms ships will have a static cable tank. You can see there on the left. It's just a large tank. The cable gets pulled on the ship, and people will physically maneuver the cable around the cable tank and coil it up. These tanks are large. You can take thousands and thousands of kilometers of cable in there to facilitate, transatlantic, transpacific laying. And more modern rotating carousels, with the increase in power cables these days, the need for laying these power cables and inter-array cables for wind farms. This cable is generally a lot bigger. I haven't done so much work with it. I know at ABL we have some expertise there, but not my area at the moment. But yes, the power cables are much larger in diameter, harder to move, and therefore the necessity to have a rotating tank to allow you to coil the cable in is driven here. These rotating carousels are powered by generally hydraulics, if the vessel has a large hydraulic system, or by electric motors. So cable handling equipment itself, in order to lay the cable, pick it up off the seabed, pull it on board for maintenance work, there's generally three types of cable machinery. This is a traditional drum engine, and it has a draw off hold back. We call that a Dobie. The draw on hold back engine basically holds tension, and you put 2, 3, 4 wraps of cable around the drum, and the friction of the cable around the drum is what holds the cable there. These are the more traditional cable engines, and they're very powerful. They can pull a lot of tension. Again, generally hydraulic powered, the ones I've seen. The ship will have a central hydraulic system that these can be connected to, but modularly or in conversion systems, they can also be electric motor driven with variable speed, variable frequency drives, that sort of thing, which is becoming more and more available. Second type we've got here, these are linear wheel pair. So much like the draw off hold back engine. I definitely didn't touch anything that time. You saw yes, a linear wheel pair. So these pinch the cable, and the wheel pairs work in tandem by pulling up and down. These are more suitable to laying activity. So big lays, they will have a linear cable engine normally out the back. The ability to pass a repeater box through there. So in fiber optic systems, the laser light diminishes as it goes through the cable. So a repeater is generally placed every, asking me a question now, 100 kilometers, 150 kilometers. So these repeater boxes are 50 to 70 centimeters in diameter, tubular, and they're about 2 meters long. So trying to wrap one of those around a drum is quite difficult. And believe me, I've done it a few times, and you end up with riding turns and all sorts of issues. So these linear cable engines, good for laying operations. Again, can be hydraulically, or this one here, you can see there's electric motors on every wheel pair. Quite a lot of electronics involved to synchronize everything up there, but they're good. Not quite as strong as a drum engine, but they can still hold enough tension. Lastly here, I've got track engines. These are becoming more prevalent with power cables. With the larger diameters of power cables, you can see there's more surface area there for holding a heavier cable. They can really grip and really pull. They're quite often, in my experience, I've seen these more as modular systems rather than built onto a ship. They can be lifted and moved around, and again, electrically or hydraulically powered. They can be mobbed up on the back deck of a ship to carry out power cable work. So that's cable handling equipment. Then we move on to supplementary equipment that may be around the ships. Obviously, cranes. A lot of vessels have cranes. Generally, on cable ships, they're not quite as large as offshore ships or as a geared bulk carrier, for example. They're just used for moving large cable buoys, large grapnel systems for picking up cable off the seabed. typically around 10 to 20 ton capacities. There we go again. Don't know what I'm doing wrong. So along with cranes, also you'll see a lot of A-frames on cable ships. Not entirely sure why they're called A's these days. I think in the old days they were an A, but these days they're more box-shaped. These you'll generally find one on a cable ship. There will always be one at the stern for launching equipment over the sides, joint boxes supporting them as they go into the water. It can also be used for ploughs and other equipment. They can have quite high capacities. I've seen 250 ton, 300 ton A-frames, so they can lift quite a bit. A-frames are also utilised a lot in launch and recovery systems. We'll get onto those later. So along with A-frames, we also have a lot of extra winches generally on board. So these are not mooring winches. They're strategically placed winches around the working decks. And this helps when trying to move cable on and off of the main cable machinery. You need to hold it, maybe adjust the tensions, adjust the directions of the cables. Also on vessels that are bow working and stern working, they'll generally lay over the stern so the vessel can proceed, en route. If you need to go around and work off the bow to conduct a jointing operation or launch a repeater or a branching unit, generally, you will transfer the cable around to the bow. These winches obviously help with that because you need to take it off the main cable machinery, hand the cable round, rather than dropping it off of the buoy. It takes less time. But this is more about the ships and not the operations. So cable handling equipment, we also then move on to modular equipment, if we come up. So yeah, the main modular equipments that you see, ROVs, remotely operated vehicles, and ploughing systems for cables. They're generally supplied as a package, so they'll come with the piece of equipment itself, but this also comes with a hydraulic power unit, workshops, containerized workshops, control cabs. These are all come, as a spread.
Paul's just going to make a quick look.
No worries.
Just check your. Okay, so
I'm trying not to touch anything there.
Right, that's you got them. That's plugged into. Oh, right. Let me just change one second.
Yeah, sure. I'll keep carrying on. I can carry on talking. So ROVs themselves, they can be very modular. We are seeing more and more built into cable ships, so they'll be built into hangars and such like. I will just wait because he's not my notes out. Okay. So we go. Let's get back onto. It's just saying that screen sharing stopped on Zoom.
Just for those online, apologies, we had a small problem with the HDMI over here, so we've just been fixing that now. Reshare. Okay.
Thanks. So modular equipment we're seeing in spreads that can be mobilised onto the back deck of ships. So ROVs, you see IMCA there, the International Maritime Contractors Association. They have classifications of ROVs. So generally, class 1, class 2, we don't really see on the cable ships that I worked on. Work class ROVs, class 3, most vessels will have one of these. If not a modular system, it may be permanently installed. And then the larger class 4s there are the big track engines. We're seeing a lot more of these with the power cables, that sort of work. Generally an ROV spread, obviously they can be very, very tailored to what jobs you're doing, but they're expensive, £10 million for a spread. The ROV itself can be up to half of that cost. And of course, it's dangling over the side, just on one cable, one umbilical, which is the power cable, the telecoms, the communications to the ROV itself. So yeah, a bit of skill involved in operating these without losing them. We've seen that before. So then that's ROV. So on to ploughing. As you can see there, nice little, just to give you an idea of how the ploughing system works. They're towed by a tow winch. So unlike the ROVs, which the umbilical is the load bearing, what's used to launch it, a plough will have a tow winch and a tow wire separate to its umbilical. The cable itself will be passed down through the winch, through the plough, and ploughed into the seabed. So again, crew, the importance of the crew and the installation managers following the right routes. There's a lot of debris, rocks, big drop-offs, all sorts on the seabed, which should have been seen prior to these operations. But if the plough gets hooked up, you know, the tension rises quickly. The crew have to react, otherwise you can part wires and end up losing expensive bits of equipment to the seabed. So there's some ploughs. That's a plough being launched there. I'm not sure if I was on board at the time, but certainly have ploughed on that ship before. And just so a reference of the size of these things, there's one on the back of a low loader. Again, with ROVs, they generally come as a spread with their own hydraulic power packs, workshops, containerized, cable cabs, but additionally you need a tow winch, some sort of control there as well. Again, ploughs, expensive spreads, you know, they're very specialist. They can be tailored to what type of cable you're doing, where you're working. They can be in the order of 10, 15, 20 million for a spread. And again, the plough is 25, 30% of the value of that entire spread. So we'd rather recover it to deck every time. And here are the larger trenches. So similar to ROVs, these are sort of class 4 ROVs, a lot bigger. I mean, those two there are not the biggest. There are some that are up to 250 tons, which are extremely big, but they're very specialist and they're not as common. These large trenches here are used quite a lot in the power cable industries. Again, you're going to need a big launch and recovery A-frame, 100 metric tons, something like that, to launch one of these. A bit more expensive than a standard ROV, not too much more, just because they're increased in size. They still have the same telemetry, the same sensors, the same systems on board. They're just bigger. So yeah, that's ROVs and ploughs. Launch and recovery systems, obviously smaller modular ROV systems. These launch and recoveries A-frames will all come with it. Work class ROVs these days, we're seeing more and more comes with a TMS, a TEMS, a tether management system, which is a cable reel, a tether reel on top of the ROV itself that gets launched into the sea. And then the ROV, when it gets down to depth, can then move off and go and do its work. These tend to be used a lot more around platforms and wind farms. It's a lot better way of managing the tether. And yet the larger systems that we're talking about, they can sometimes need a bigger crane these days, not an A-frame we've seen. I haven't worked much with those, but they're very specialist and they'll be purpose built on board. So just to give you a visualization, there's a tether management system there. You see the ROV itself and the coil of cable on the top. All of that gets launched into the water, and then the ROV itself can move away from the tether management system. A tow winch, very agricultural bit of kit, but very important. Lots of sensors on board need to be calibrated for the load to know what's happening with the plough. And then a launch and recovery, just an A-frame there, just to show that they are very modular, can be moved from ships to ship. So yeah, that's coming to the end. So hopefully you've had a brief understanding of the history of the telecoms cables. That could be a presentation in itself. That's a very long history there. Hopefully I gave you a little understanding. Structural differences with the ships, how they're not just off the shelf, off the rack vessels. They can be very specialist and therefore cost a bit more money. And understanding into the cable laying equipment itself. And of course, there we're talking about ROVs and ploughs. Hopefully that's helped. So, any questions? Yes.
I'll ship it with Marsh. You showed a cutaway of a cable ship with three drums in.
Yeah. Depends on a full weight. I mean, they can take thousands of tons. Yes, 5,000 tons of cable can happily be taken. It depends on the vessel, obviously the size. Some vessels are larger than others and capable of carrying more. You'll tend to find the cable ships that are designed for laying will be a lot longer and have larger cable tanks. The ones that have been designed for repair work will be a lot smaller. May not quite have the same capacity, but yes, 7,000 tons of cable, not unheard of. Yes, another question. So generally within lays, you will have a marine warranty surveyor overseeing. If it's damaged, the cables are tested on board, so that there will be a cable team on board. They'll test the cable while it's in the tank. You can run a light through it and check that everything's okay. Once it's laid, they'll then test it again before they connect it to a system. You can tell where the damage is generally by the distance that the laser light goes. Machines that work it all out. So if it was to be damaged, you would hope you would see it when you did it on the ship before you sent it over the side. But if you have laid it, tested it, it would then be pulled back up basically, and you would recoil it back into the tank. Would be a long, slow process, and hopefully it wouldn't come to that. Alternatively, you could continue with the lay, connect the system, and then go back and make a spot repair. Just depends on what timings you have, the project scope, and things like that.
Here's some questions.
Yep, sure.
Could you shed some light on the challenges of using ROVs, ploughs, and trenching equipment, specifically in dynamic nearshore shallow water environments?
Yes, it's tricky. I mean, I know there are some vessels out there that have been designed to, you can actually take the vessel up at high tide and then allow the tide to go out. The vessel will actually sit on the bottom, and then you can launch a plough or an ROV. But generally, these ROVs, the seawater around them cools them as well. So you need a very specific specialist plough or trencher to be able to do this work out of the air, in the air, sorry, because it would overheat quite quickly. So that's some challenges. Is there any other part of that, or has that answered it? Not sure. That's answered.
While to deal with adverse weather, any thumb rule experience-based criteria?
It's very much dependent on the installation team. The captains of the vessels are generally very experienced and have been cable ship captains, cable ship crew for a long time. Some of the larger purpose-built vessels can handle some really severe weather. I've been bouncing around in the Atlantic in force 12s with cables still hanging off the back of the ship. If it is deemed too much, certainly in more shallower waters, the risk of damage to the cable is greater. So the weather criteria would be reduced. Deep sea, transatlantic, transpacific, you have 7,000 to 10,000 meters of cable at the deepest points hanging off the back of the ship. You've got quite a large room for error in that process. So yeah, it's all dependent on the captain itself and the crew and how they see the conditions. Good.
I don't know if this is one, but has armoring of fiber optic cables improved in the last 30 years, especially regarding seismic activities?
Not as far as I'm aware with armouring cable. So armoured cable is generally ploughing of fibre optic cables into the seabed only happens down to about, depending on where in the world, 500 to 1,000 meters of water depth. After that, it's polypropylene. It's tiny little, like a garden hose. So the armouring itself, not as far as I'm aware. We tend to have deep sea cable. You had single armour and double armouring for around the channel is is all double armored cable. But no, I don't think there's any significant changes in it. Not that I've seen in the last 10 years anyway. Yes, yes, of course, yeah. Yeah. Yes. Well, that's use the onboard. Oh, sorry. Yeah. If we have damage to you've laid a cable into 7,000 meters. If it's damaged, how would we go about it? It's a very long process. Grappling hooks. It's very archaic. You would think we have ROVs to do all of this. Past most work class ROVs on cable ships will only work down to 200 meters. Past that, we do have deep sea capabilities with ROVs, but generally we'll resort to where the cable is, or you hope to know where the cable is. So you go past that, put a grappling hook over the side, pull that along, and you monitor the tension on the rope. Once you get a spike in tension, we start heaving up, and hopefully it's on the end of the grappling hook. Yeah. Yeah. It does, yeah. Yeah. So when you get it on board, you'll cut it. There is enough slack generally. You will be able to bring it up. You can bring it up. There are also, when you're doing slightly shallower ones, you can get grappling hooks which cut and hold. So cut and hold, flatfish is a type of grappling hooks. Perhaps I should have put some up, sorry. But you can cut and then it will hold one end of the cable and pull one end up. Once you've done a repair, you've jointed in both sides, you will lay a bight onto the seabed. So if you look at the Ordnance Survey maps now, you see the cables that have been repaired because the lines will be all wiggly, and that's generally because of repairs. So yeah, it's frustrating if you miss a run at 7,000 meters, because you would think a grappling hook would hit the seabed quickly, but it doesn't. It can take 18 hours to get to the bottom of the seabed, 18 hours to pick it back up, and if you've missed it, you do it all over again. So it's it can test your patience. Any more? One more? Yeah, sure. Yeah, go for it. Yeah.
For electric power cables, can high voltage DC sheath testing be done on the vessel before lay? What are the limitations?
That's outside of my area of expertise. Yeah, no. Apologies, that's not my area. I'm more of a ship's engineer than a cable engineer, unfortunately.
Are there any additional risks associated to cable laying barges?
Additional risks. It depends. That you can have self-powered barges I've worked on in the past are not too dissimilar to cable ships. Obviously, if you look at a traditional cable ship, the form is much more traditional vessel form, so they can cope with a lot more weather. A flat top barge, a flat barge would struggle in heavy weather and heavy seas. So generally, they're only utilised anyway around near coastal work, and I haven't seen any transatlantic lays on a barge. I don't think that would ever happen. So yeah, weather is probably a big part in that. Thank you very much.